Hi, everyone. Welcome to the Planetarium at Raritan Valley Community College. My name is Amy. I'm the Planetarium Director. Come on inside and join me for a tour of the exhibit area. Come on. This is a full-size model of a Mercury space capsule. Not a scale model. This is how big the actual Mercury capsule was that the first astronauts took into space. This is a model of the Friendship 7. It was built by some people who make sets for middle school plays here in Somerset County. And you can even climb into it. There's not a lot of room, but John Glenn made it in here and orbited the Earth back in 1962. You can even lay down in the chair like he did. One of the first things you'll do when you come to the planetarium is to come down the tunnel. This leads you to our exhibit area behind me. Luckily for us, the tunnel was built to be the same size as the real Hubble Space Telescope. It's about the same width and about the same height and even the same length as the real Hubble telescope. I'm standing next to an iron meteorite that we have on loan from the American Museum of Natural History. We call it the Canyon Diablo meteorite because it was discovered in Canyon Diablo at what is now called Barringer Crater. This crater is 4,000 feet across. That's about 3/4 of a mile and more than 500 feet deep. It was created by a much larger meteorite than this one. This is just a small piece of the original one. And it hit the ground, broke into many pieces. We also have a smaller version of it as well. I love to show off the smaller version with an earth rock of the same size so that you can put them in your hands and hold them and decide which one is heavier. Hint, the iron meteorite is heavier. Iron weighs a lot. Our iron meteorite is about the same size as a beach ball. The beach ball is very light. The iron meteorite weighs 142 pounds. Wow, that's really heavy. I'm standing in front of our picture of the Whirlpool Galaxy. This is a spiral galaxy. You can see that because of the spiral shape to it. It is made of probably about 1 trillion stars. There are lots of red splotches in the arms of the spiral galaxy. These are star-forming regions. So new stars are being created in the arms of the galaxy. Not in the center, but we see the red nebulas in the arms of the spiral galaxy. This is not the only galaxy in the picture. If you look over on the far side, there's another white splotch. That is another galaxy, another collection of stars. It is slowly being drawn into the larger Whirlpool Galaxy, and eventually they will combine together. Next to me is a model of the Space Shuttle. For 30 years, the United States used space shuttles to take astronauts, satellites, and parts to build the International Space Station up into space. The Space Shuttle was an amazing piece of equipment. It launched like a rocket, but then it landed like an airplane. It was kind of used as a truck. Like a truck brings things to a store, the space shuttle brought things up into space. Sometimes it was satellites like the Hubble Space Telescope. Other times it was parts to build the International Space Station. And now we have astronauts from a number of countries living and working together at the International Space Station, which continues to orbit our Earth. This is the Hertzsprung-Russell diagram. That's a big name. But what is it showing us? It's really a chart of sizes and temperatures of stars. Now, when you think of a star, you often think of something that has 5 points on it. But real stars in outer space are round balls. They do come in different sizes and different colors. In this chart, the small or dwarf stars are at the bottom, and large and supergiant stars are at the top. The colors tell us about how hot the star is at the surface. Red stars are the cool stars. They have a surface temperature around 5,000 degrees. Yellow stars, like our sun, have a surface temperature around 10,000 degrees. And blue stars at the end, they have a surface temperature of more than 20,000 degrees Fahrenheit. So in art class, we learn that red is a hot color and blue is a cool color, but in science, it's the other way. Stars have different life cycles. They're born, they live, they die. But depending on how much mass is in a star, it can lead to a different ending of the star and how long it lives. So here we can follow the arrows for a small star. Our sun is considered a small star. Our yellow sun will become a red giant and then puff off its outer layers, creating a planetary nebula, ultimately becoming a white dwarf. Large stars, like Spica, will eventually explode in a supernova explosion, and they might become black holes at the end of their lives. Sometimes it's hard to tell how big things are, because when we see pictures, everything fits on the page so nicely. So here we have a description of different objects and how big they are compared to each other. At the top, we can see the Earth. Venus is about the same size as the Earth, but at that scale, we can only see a little bit of Jupiter. More than 1,000 Earths can fit inside of Jupiter. So let's shrink things down so we can see all of Jupiter. Now, Earth is a ball about 1 inch across, and we can only see a little bit of the sun. More than 1 million Earths could fit inside of the sun at the same time. Let's shrink things down again so we can see all of the sun. Now, Jupiter is 1 inch across, and Earth is just a dot. Shrink things down again so the sun is a 1 inch ball. Jupiter is a dot, and now you can get an idea for how big red giant and blue giant stars are compared to our sun. Astronomers use multiple wavelengths to look at the sky. We do that because there's a lot more that you can see with just your eyes. We also use X-rays, ultraviolet rays, and infrared light. So we've added a new exhibit to the planetarium about infrared light. You can look through some things and some things you can't. How about a black plastic bag? You can't see my hand in visible light, but in infrared light, you can see my fingers hidden inside that dark plastic bag. What about glass? In visible light, you can see my face. You can see my face with and without the glass. But what about in infrared light? Can you see me? Now you can see me. But with the glass in front of me, you can't see my face. But I can see you. So there are things hidden from our eyes in visible light that when we use other wavelengths of light, they become revealed and we can see them in other galaxies. Well, thank you so much for visiting us here at the Planetarium at Raritan Valley Community College. We hope to see you soon. Have a great day.